Hello, my name is Benoit Girard, and I want to demonstrate the profiler we have been working on. Now, this profiler is a little different than the typical profiler you're used to. The biggest difference is that it's built in within the browser, and all you have to do is set a pref and you leave it always running. Now, this profiler has aims to have as low overhead as possible while still gathering useful statistics. And the aim is that power users would leave this profiler running on their day-to-day session, or even in certain cases we could let we could have instructions for non-power users to quickly flip on the profiler, collect the data and flip it off without having developer tools installed on their machines. And once we have this installed, I'm going to go ahead and show you samples. We're going to pull up a WebGL demo. As we can see at the bottom, we have an extension showing us that we're not being responsive, and then that's an indication that you should go and dump a profile. So right now I'm still working a bit on some allocation scripts. I'm going to start them right now as I keep explaining this. These take a couple seconds. As we can see here, what this number represents is that once we turn on the profiler, we start sending tracing events in the event loop. And these are just events that keep going in the event loop. And if these events are not processed in a reasonable amount of time, this number goes up. And that means that we're not responsive to user interaction, because these events are added to the same queue that mouse event, keystrokes, user interactions, and painting is being processed on. So if we're not responding to these events in a reasonable amount of time, that means that our users are getting sluggish experience. Another notable difference with the data that's collected is that we're profiling using wall clock time as opposed to CPU time. So we're purposely profiling even when we're blocking, because if we're blocking waiting on graphics drawing or just synchronization locks, even though we're not spinning the processor, we're still not responsive to the user, and that's why I think it's important to care about those and measure them. Now with this profiler here, this is the result of the data we've gathered, and here I have a timeline. So on the x-axis there's time, on the y-axis that's just the stack depth. That's not particularly useful. What is useful in this are the colors for the bars. As you can see, most of the bars are black, and that means that while we were grabbing that sample, we were responding well to the event loop, that the browser was responsive. Now, in the cases where the tracing event took a while to be processed, we start fading the black into red, and once it reaches red, it means that we've exceeded the threshold of 1 second. So as we're going here, we've spent about 4 or 5 seconds without responding to user events. As you can see here, I have the ability to select ranges that I'm particularly interested in, and I can go and look at the samples and see what we were doing. For example, in this case, we were doing some WebGL drawing. Specifically, we were spending our time in finish memory buffer IO connect call method. And we can look at specific ranges. I can drive down and see what we were doing within the startup. So processing events, doing memory allocation. And then we can look at where we were spending our time during the drawing. This right now is just a temporary UI, but the aim is that we would spend more time working on this UI and also spend more time working on this extension that lets you generate profiles more easily. Right now I generate profile using a shell script, but the idea is that we would remove as much of these steps as possible, and we would move this UI into a web, just a web application. And the end goal is that once you flip on this profiler and you want to look at the data, all you would have to do is just right click and say analyze this profile. Another tab opens with a web application that could process your profile and symbolicate it and then display the results into into a view that looks similar to this, maybe with more information along the timelines, better markers, better symbolication data, better ways to filter, more intuitive UI. And once we have that, we have something really useful where we could start filing bugs against places where we're hanging, not responsive, and we can start and we can link these profiles directly on the bugs. The focus while designing these profiles that we're gathering is as long as you have the symbols associated with that, we can easily transfer them between developers once you've symbolicated the profiles. Or if you have the necessary data, you could symbolicate it on the server side. Anyways, there's oh right, and the goal we're trying to do is have this. Right now, this profiler works well on Mac 32-bit, but the idea is to have this work well across all platforms, including Windows, but particularly Fennec, where right now it's very hard to get profiling information to know where we're spending time. The idea is with this tool, we can make it accessible to more for users that wanna debug and look at performance metrics. There's lots more features that we have planned for this. Right now, the patches are in. We have some patches that have already landed. We're landing more patches. There's a lot of features that we need to do to get everything working properly, but we're starting to have some interesting proofs of concept you can start hacking around with. So please stay tuned. If you have some time, you want to contribute and help us out. We still need help porting it to platforms, writing better visualization tools, and just general improvements. So if you're interested in that, just contact me.